derivation for the expression of kinetic theory of gases. So kinetic theory of gases, we have one expression, that equation we are going to prove. So that expression I am telling you, first of all, that is a PV is equal to 1/3 mnu square. PV is equal to 1/3 mnu square. This expression we are going to prove. So of course you know what is P. P is a velocity, V is a volume, P is a pressure, P is a pressure, V is volume. It is the pressure of the gas, V is volume of gas, M is mass of one particle, mass of one gas molecule, and one gas molecule, right? And N is number of molecules, N is number of molecules, and U is RMS velocity. Yes, we will also learn what is RMS velocity. Its full form is root mean square velocity. Root mean square velocity. We will go for the derivation. Okay, now let us see the derivation. Yes, in derivation there are some considerations, means some terms we are going to use here. So what are those considerations? Let us see. This is a container. It is a container. I am talking about only one molecule first, molecule number 1. So let us say the molecule is at this position, starting point. Let us say this is a starting point. The length of this container is L. So where L is equal to length of container or path of the object or the gas particle, and Vx is velocity of molecule, first molecule in x direction, or along x axis. Similarly, Vy, that is velocity of the molecule in y direction or y axis, and Vz, it is velocity of the molecule in z direction, and V1, is total velocity of molecule, total velocity of molecule. Only one molecule I am talking about, only one molecule, keep that in mind. Let F is force acting due to collision, force acting on walls of container due to collision, right? So now I am going to derive the expression. Very simple derivation. You must have seen many videos, but this is a very simple derivation I am giving you. I want to find the force. Force is equal to, you know the formula, mass into acceleration, right? F is equal to m into ma. M into acceleration means what? dv over dt, change in velocity over change in time. Let us keep this as the equation number 1. Let us find dv, change in velocity, is equal to dv. If this molecule is moving in this direction along x-axis, its velocity is vx. And if the same molecule is moving in the opposite direction, because after force collision it will come back again, so its velocity is going to be minus vx. Got my point here? The molecule is here, it's with a velocity vx, striking on the walls of container, and it is coming back again, so with velocity again minus vx, with the same velocity. There is no loss of energy. That's what we studied, that because the collisions are elastic collision. We said the collisions are elastic collision. Elastic collision means velocity will not be lost, so it is coming the same. So now dv is equal to what can we say? Initial velocity minus final velocity. What is the initial velocity here? Vx minus final velocity is minus Vx, so is equal to 2Vx. Got my point? That is a dV. Now I have to find a dt time. How to find? That is a big question. How to find time? We know that speed is equal to or velocity is equal to distance over time or displacement over time. If I talk about velocity, I will write displacement. Okay, displacement over time. Now time is equal to what will come? Displacement. Time is equal to displacement over velocity. Now that is what I'm going to get. Displacement, it is going to be displacement over velocity. So displacement, here the object or the particle moving L distance, and again it is coming back to the same point for another collision. So I am talking the distance between two successive collisions. The main point is force acting due to successive collisions. So this one point, it is moving the L distance and again coming back the L distance. That means the total displacement between two successive collisions, it is equal to 2L with velocity Vx. Got my point here? So now I got dV as well as dt. So both I can put in equation 1. So from equation 1, what can we write? Force is equal to m into dV over dt, which is equal to m into dV, 2Vx upon dt, 2L by Vx. So 2 get cancelled, so which is equal to half m into Vx square. Got it? Now come next. What expression we got for force? Force is equal to, if you see, there was a mistake here. That's actually 2 get cancelled, which is equal to m by L into Vx square, right? That is the expression which we got now. So force is equal to m by L into Vx square. This is equation number, let us say 2, right? Equation number 2. Now we know that in the beginning of the postulates we studied, we know that the velocity of the first molecule v1 square is equal to vx square plus vy square plus vz square, but the velocity is the same in all directions. So that's why these all three will be going to same. So we can write 3 vx square. So vx square is equal to, what can we write? 1 by 3 into v1 square. So this value you can put in the equation 2. Now from equation number 2, what can we write? Force is equal to m by L into 1 by 3 into v1 square. Now force, what do you mean by force? Force is equal to pressure into area, is it right? Force is equal to pressure into area. So you can write pressure into area is equal to mass over length of the container into 1/3 v1 square. So length you can bring this side. So pressure into area into length is equal to 1 by 3 m v1 square. So area into length, it becomes what? Volume. So PV is equal to 1/3 m v1 square. Now this is the equation number 3. Let there are n1 molecules with velocity v1, with velocity v1 and n2 molecules with velocity v2, n3 molecules with velocity v3. Therefore, from equation 3, the net pressure into volume is equal to 1 by 3 m n1 v1 square plus 1 by 3 m is a constant because mass is always common, because all the masses, all the gas molecules have same mass, n2 v2 square plus 1 by 3 m n3 v3 square plus so on. Now net pressure into volume is equal to 1 by 3 common into m common, n1 v1 square plus n2 v2 square plus n3 v3 square plus so on. Yes, now what I'm doing is I'm simply multiplying the total number of moles and dividing. So I can write 1 by 3 m into n1 v1 square plus n2 v2 square plus so on, divide by total number of molecules n and multiplying the same number, total number of molecules. Right, why I am doing, I'll tell you. Because this whole part is only called as RMS velocity. I'll explain what is RMS velocity. First note down this one. So this can be written as 1 by 3 m. This is a square root of RMS velocity. So m u RMS square. I will tell you what is a u RMS also. So first note down this one. So this is the formula. Into n also is there. N is the number of molecules, total number of molecules. So PV is equal to 1/3 mn u square. Now coming to the continuation, you can ask me what is RMS velocity. RMS means root mean square. Root mean square. So generally what is a mean velocity? Suppose you have n1 molecule with v1 velocity, n2 molecule with v2 velocity, n3 molecule with v3 velocity, and so on. This is number. Now mean velocity, what can we find? n1 v1 plus n2 v2 plus n3 v3 so on, n1 plus n2 plus n3. This is called mean velocity. But now I am doing square. So that is square root mean square. Now I am putting root. So this is called root mean square, that is URMS. So here, that's if you can do square, URMS square is equal to n1 v1 square plus n2 v2 square plus n3 v3 square plus so on, divided by n1 plus n2 plus n3. This is what I have used in the previous expression. I will show you the expression also. You see here, this one n1 u1 square plus n2 v2 square plus so on by n1 plus, it is nothing but n1 plus n2 plus n3. So that is what I have written here. This one n1 v1 square plus n2 v2 square plus n3 square upon n1 plus n2 is equal to URMS square. So I repeat, RMS means root mean square. See, first of all you have to find mean. How do you find mean? n1 v1 n2 v2 n3 v3 divided by n1 plus n2. Now I am doing square. So that's mean square, and square root. So that's called root mean square. And to remove that square root, I am putting the square. This value I have substituted here. You can see. That is where I have written RMS square. So PV is equal to 1/3 mn u square. A derivation is done. So finally answer PV is equal to 1/3 mn u RMS square. Now you may ask me, sir, what kind of questions can come in this one? So that I'll explain in the next video, because it's already long video. So people don't like actually long videos. That's why I'll make the numericals in the next video. Here I can add one small point. For 1 mole of particles, suppose if you have 1 mole of molecules, then small n will become Avogadro number. It become Avogadro number, right? So PV is equal to 1/3 m into Avogadro number into URMS square. Here m into Na, mass of one molecule, it becomes 1 mole of molecules, which will become now molar mass. Which will become molar mass, means mass of 1 mole of molecules, right? And here small m is mass of only 1 molecule. Got my point? This is 1 molecule, this is a 1 mole of molecule. So here I can write PV is equal to 1/3 molar mass symbol capital M into URMS square. This is the final formula which you are going to do in numericals. Understood? Now the next class we will explain you the kinetic theory of gases, relation between kinetic energy and temperature. Just have a look at this derivation. Derivation, many people explain the derivation, but this is a very simplest possible way. The derivation is this. I am explaining you once again. I have taken force is equal to mass into acceleration. Acceleration means dv by dt. dv means velocity, you can see. Initial velocity vx and reverse minus vx. So vi minus vf, it is equal to 2vx. And distance, velocity is equal to displacement over time. So time is equal to displacement over velocity. Displacement means length. From here to here 1L and again one more strike. It means the distance between two collision. Here one object is there. It is going to that place, striking and coming back to the original point. That distance is called the distance between two successive collisions. That is 2L. And velocity is Vx that I kept over here. So from equation 1, m into dv by dt, 2 get cancelled. So m by L into Vx square. Now m by L into Vx square is here. And we know that V1 is equal to Vx square plus Vy square plus Vz square is equal to 3x square. And Vx square is equal to 1 by 3. This I have kept in the formula. Area into length, it is a volume we got. Now N1 molecule with velocity V1, N2 molecule with velocity V2 and so on. So now the net PV means pressure into velocity is equal to this one. Here this 1 by 3 m is taken common, divided with its total number of molecule and multiply with total number of molecule. It becomes square of RMS value. How square of RMS value? That I have explained here. What is RMS value and what is its square? So that is PV is equal to 1/3 mn URMS square. Now for 1 mole of molecules, n is equal to Na. That you can put here molar mass, and finally we got the derivation. I hope you understood this one. So still, if you have anything to say, put it in the comment box. Thank you guys.
Subscribe now and press the bell icon. Never miss an update. Subscribe now and press the bell icon.